Okay, so we're going to continue on with trigonometry and make this a little bit harder. So today we're going to find a missing angle instead of a missing side like we did earlier. So identify the angle. So first step, identify the angle and its sides. So just like we did to solve for sides. So you're going to find the hypotenuse and the opposite and adjacent. And really you want to just label the sides that have values on them to make it less confusing. So you're going to only label 2 of the 3 of these. You're going to set up the equation using, again, sine, cosine, or tangent, depending on which sides you have. Now, to solve for an angle, you are going to use what's called inverse trigonometry. And those are different buttons, or sometimes you have to use the second key and then push the sine, cosine, or tangent. But I'll show you what that means. Okay, so find the value of x round to the nearest degree. So we're going to the whole degree for the angle measure. Number 1, obviously we have this angle here that we are talking about. We have the 24 labeled. That is going to be opposite of the x. We have the 29 labeled. That is across from the right angle. That is going to be the hypotenuse. Now, always, 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 we're going to write SOHCAHTOA at the top of your page. It's always just a great thing to remind yourself of on every single page. So in this particular case, I have the opposite and hypotenuse. So that is going to be the sine function, opposite over hypotenuse. I'm going to set things up just like I did previously. So I know it's the sine of the angle is x this time, and that is equal to opposite over hypotenuse. Okay, so this is my setup. Very similar to what we did before. But notice that the x is in the angle position. So there's nothing that I can do in a calculator where I can just plug in sine of x. That doesn't make sense. So that's why we need a different button to help us. So that's where inverse trigonometry comes in. So basically, because you can't plug in sine of x into your calculator, you're going to use what's called the inverse sign. Okay, the inverse sign has a little -1 above it. So what you do is you do the inverse sign of the fraction. That is obviously what you can plug into a calculator, and that is going to be equal to x. Okay, so looking at a calculator. So again, in your geometry folder, you have this scientific calculator that you can use. And I'll just show you. So you have sine, cosine, tangent here. If you hit this function button, you'll notice that you have also inverse sine, inverse cosine, and inverse tangent. So I'm going to do inverse sine. I am going to plug in 24 divided by 29, and it does the fraction for you. So I don't need that there, so arrow over. So in the calculator, basically what this is saying is if the sides are in a ratio of opposite over hypotenuse, inverse sine will get me an answer that is an angle. So this represents an angle for that particular ratio of sides. So to round that to the nearest whole angle measure, that would be rounding up to 56 degrees. So I go back to my work here, and this is going to be 56 degrees is equal to x. Now, if you look in your trigonometry table, like we did the other day, so I can actually zoom in on this. A little bit. So here, if you look at 56 degrees right there, and then you look at sine, you see that you have this 0.829. Well, if you go back to the calculator, and if I just plug in 24 divided by 29 and hit enter, I get 0.8276 basically. So it is an estimated answer, but very, very close. So 0.8276, 56 degrees, so 0.829. So very close to what we needed. These are all estimated answers, in fact, but so I look up sine, I look up 24 divided by 29 is about that, so therefore my angle is about 56. Okay, so going back to the normal size, I thought it would just go back to the normal size. Let me just go, there we go. Okay, so let's try this next one. So I'm going to give you a moment to try and at least identify the sides and set up this initial equation. So pause and try that. Okay, welcome back here. So you're going to have angle x here. 20 is the hypotenuse. So I'll set up hypotenuse. Opposite doesn't have a number on it, so therefore the 9 is the adjacent. So if I have the adjacent and the hypotenuse labeled, that is going to be cosine. So my setup should be cosine of the angle is equal to the adjacent over hypotenuse. So that should be your setup. And again, if I'm solving for an angle, I can't plug this in the calculator. So that's when I'm going to use my inverse trig. Equals x. Okay, so going back over here, I'm going to clear this out. I don't know why that's doing that. Okay, now I've forgotten what it is. So 9 over 20. So inverse cosine of 9 over 20. So inverse cosine, I do 9 divided by 20 and then hit enter. So this is again the angle measure that goes with these two sides as a cosine. So the angle measure is going to be 63 degrees. So my final answer here is 63 degrees is equal to x. Okay, and then there's that table again. All right, another type of problem. So what this is called solving a triangle. What that means is you are going to find, given this information, you are going to find all of the angles and all of the sides. So 3 things are always going to be given to you in some way or another. So you can always write down 3 things. So obviously angle C here is 90 degrees. BC, the length of BC is 7 inches. AC, the length of AC is 4 inches. Now, if you are given 2 sides, the first thing I would do is the Pythagorean theorem. Okay, so the Pythagorean theorem in this case, obviously hypotenuse is across from the right angle. So I'm going to have 4 squared plus 7 squared is equal to c squared. 16 plus 49 equals c squared. So 49, was that 59? So 65 equals c squared. And so c is the square root of 65. Now you can see if there's a perfect square that divides in there. Only one that I would think would be 25, but it doesn't. 25 goes into 75. So we know that AB is the square root of 65. Okay, so now let me erase that C and I will put square root of 65 there. All right, so now I'm going to figure out each of these other angles. What you can do for that, so maybe I'll put a 2 here. What you can do for that is several different things. But since these guys are whole numbers, the 4 and the 7, I would just use those. It'd be easier than using the square root of 65. So I'm just going to start with angle B. Maybe I'll do it in a different color. So I'll do angle B with green. Okay, so I'm going to do exactly what I did above. So if I'm looking for angle B, so I'm looking for this guy, I'm going to label the sides. So the 4 is opposite and the 7 is adjacent. And then you see SOHCAHTOA at the top, but I'll write it here as well. So SOHCAHTOA, opposite adjacent means I'm using tangent. So I would set up tangent B, I don't know the angle, is equal to 4 over 7. Again, I can't put that in my calculator, so I'm going to do inverse tangent of the fraction, and that will be equal to B. Okay, so I go over to my calculator, 4 over 7, and I do inverse tangent, 4 divided by 7, and I get out an answer rounding up to 30 degrees. So I know that B equals 30 degrees, and I can write that here. All right, third, you always want to take the easiest route. So if I know this is 90 and I know this is 30, I can use the triangle sum to figure out angle A. So I'm basically going to say 30 plus 90 plus the angle A is 180, and therefore A is 60. So the measure of angle A is going to be 60 degrees. That is always going to be the easiest way to figure out your third angle. This is always the easiest way to find the third side. So really just somewhere in between, you are going to have one trigonometry problem to figure out either an angle or a side to help yourself. Okay. All right, some more, since we have a couple of minutes, some more special right triangles. So find the perimeter of the big triangle. So first of all, whenever you are doing a special right triangle problem, I do want you to use radicals and not trigonometry. Okay, so we're going to start with the short side. Short side would have to be A. So this is going to be times 2, and this is going to be times root 3. So starting off with this triangle, 18 root 3, and I'm going to say something times 2 is 18 root 3. So this is going to have to be 9 root 3. And then you take 9 root 3 times root 3. That is going to be basically 9 times 3, which is 27. Okay, on the other triangle here, it's going to be 45, 45, 90. So if A is 9 root 3, we know that D is also 9 root 3. And then here we have a times root 2 problem. So 9 root 3 times root 2 is going to be 9 root 6. Okay, so we'll keep throwing in this old information just so you don't lose that skill while you're adding on the trigonometry skills. Okay, good job. We'll see you next time.